Today we're going to talk about cladistics.
Professor, what's cladistics?
Cladistics is a classification system used for all known life, extinct and present. It's an organized way to show how an organism, or group of organisms, are related to one another, and who evolved from whom. Cladistics is formed by clades, nested within one another, and we illustrate this by drawing special charts called cladograms.
So a clade just shows who evolved from whom?
Not exactly. A clade shows who is related to whom through a last common ancestor. This is where a clade begins, and then it can branch off into different evolutionary trees.
What's a last common ancestor?
A last common ancestor, or LCA, has traits or characteristics that all organisms after the LCA share.
So how do you decide where to start a clade?
You can start a clade anywhere you like, so long as you start with an LCA. But first, you need to pick at least one synapomorphy you want to look at, and pick the LCA associated with those traits.
So synapomorphy is just a trait?
Synapomorphy is a shared trait found among two or more groups and their most recent common ancestor, but whose ancestor does not possess that trait. It's an animal, and its ancestor didn't have four limbs and didn't have a backbone, but its descendants did.
So we can start a clade with a four-lobed fish. Then what?
Remember, we can start a clade anywhere, but yes, we can begin with the four-lobed fish. We need to go through all life and find all other organisms that have four limbs and that are an animal and have a backbone. So let's begin. A tiger. That has four limbs and is an animal and has a backbone, so that goes in the box.
I have a flower that doesn't have four limbs and isn't an animal. Where does it go?
It doesn't belong in this clade, so we can throw it out. Here's a snake. It goes in the box.
Hey, wait a minute. You said it has to be an animal and have four limbs to go into the box. The snake is an animal, but it doesn't have four limbs.
That's true, but it evolved from an animal with four limbs, and they're both related to the four-lobed fish.
That's a pause.
All right. So also we have a very surprised lion. He's all like, "Oh, look at me. I didn't realize cladistics could be so interesting. I'm so surprised." But it doesn't have to just be a mammal. As you see, we've got a spotted lizard. We have a starfish, also four limbs. And, fun fact, get a very dedicated bear with a starfish, and you have a ninja bear. Now, on top of this, we have the four-legged spiky dinosaur. Scientific name. Spitting frog, troll frog, jumping frog, man, woman, Sheldon. I think this is a tyrannosaur, also four legs. Four legs, count them four, still four, no more, just four. Four again, monkey, Mexican for pollo. Giraffe, also four legs. Sultry zebra. That glare just lights you on fire. Four legs as well. Bird. Four limbs. Two legs, two wings. The wings used to be legs, but now they're wings. Parrot. Same story. Other bird. Same story. Turtle. Four limbs. Snake. Also used to have four limbs at one point. Oh my god, it's a ninja turtle. Crocodile, four limbs. Iguana, four limbs. Thing, four limbs. This one. Bug. I think the wings count. Other iguana, or maybe chameleon. Coral reef, mayhaps? has far more than 4 limbs and is a plant. Or rather, a buildup of mollusk, I think. So no. I don't know what this is, but it doesn't look like it has 4 limbs. Other starfish, of course. Flower, no. Bird, yes. An octopod. Oh my god, it's a ninja octopus. No. And that, kids, is the 4-limbed cladistic.
Stop.
Now all the organisms in the box are animals that either have 4 limbs, evolved from something with 4 limbs, and have a backbone.
Now we need another synapomorphy. Let's look at amphibians. What do they have that the 4-lobed fish doesn't have?
Amphibians have moist skin, breathe through their skin, are ectotherms, and lay their eggs in water.
Now we need another synapomorphy. Let's look at reptiles. What do they have that the 4-lobed fish doesn't have?
Reptiles are the first animals that completely do not need water. They have dry, scaly skin, lay their eggs on land, have a sprawled stance, and are quadrupedal.
Now we need another synapomorphy. Let's look at mammals. What do they have that the 4-lobed fish doesn't have?
Mammals have fur or hair, are endotherms, give live birth, and have a large brain.
Every mammal has a large brain. You're sure of this?
Of course, they also have 4 limbs and vertebrae. But we still have birds. What about them?
Wait and see. Now let's change it up.
Okay.
We can look at one of these groups we made more closely and make a new cladogram. This is what a cladogram looks like. We begin with the last common ancestor, 4-lobed fish, and as we move up the cladogram, the organisms get more and more complex. Let's begin with the amphibians. The amphibians are less complex since they need to return to water, so they go in the first group. Next come the reptiles. The reptiles are an advancement over the amphibians because they can lay eggs on dry land. So they'll go in the second group. The mammals are the presently most advanced, since they are big-brained and endothermic, also known as warm-blooded. So they go in the third group. Now we've removed a branch from our original cladogram. We will form a new cladogram just from the reptiles.
The last common ancestor of this clade is a primitive reptile. It has scales, a backbone, a sprawling gait, and dry skin.
The lizards and snakes are more advanced than our last common ancestor, and the crocodiles are more advanced than the lizards and snakes. The dinosaurs are located within the reptile clade.
The dinosaur clade can be broken down into 2 initial branches, the ornithischians, which includes herbivores, and the saurischians, which include the huge sauropods and ferocious meat-eating theropods.
Synapomorphy? I still don't get it. What the heck is a synapomorphy? Sounds like a new rock band.
Here, look at this cladogram. A synapomorphy is a shared derived trait. This means that it is a new beneficial trait that appeared in an animal or plant. This animal is the last common ancestor that begins the clade. The trait is shared by two or more groups and the LCA, but not the LCA's previous ancestor. Okay, pretend we're on another planet with some very odd animals. All the primitive animals on this planet have only 2 eyes. So the first animal, the purple guy, has only 2 eyes and is not part of this clade. The blue guy with 3 eyes is the LCA, and the synapomorphy, or trait that helps describe this clade, is having 3 eyes. Again, the trait of having 3 eyes helped define the clade. All more advanced creatures in this clade have 3 eyes. All animals with 3 eyes belong in this clade, and having 3 eyes is the synapomorphy that helps define it.